Things that people did. For example, Maxwell put the equations together. The Faraday formulated the equations mathematically with some model in his head. And then Dirac got his answer by just writing and guessing an equation. And other people got their answer, like in relativity, got the idea by looking at principles of symmetry. Now, all these methods, and Heisenberg got his quantum mechanics by thinking only talk about the things that you can measure. Now, all of these ideas, we should only talk about things that we can measure. Try to define things in terms of only things you can measure. Or let's formulate the equation mathematically. Or let's guess the equation. Or all these things are tried all the time. Look for symmetries. All that stuff is tried. All that stuff, when we're going against the problem, we do all that. That's very useful. But we all know that. That's what we learn in the physics classes, how to do that. But the new problem, where we're stuck because all those methods don't work. If any of those methods would have worked, we would have gone through there. So when we get stuck in a certain place, it's a place where history will not repeat herself. And that's what makes it even more exciting, because whatever we're going to look at the method and the trick and the way it's going to look is going to be very different than anything that we've seen before, because we've used all the methods from before. Therefore, a thing like the history of the idea is an accident of how things actually happen. And if I want to turn the history around to try to get a new way of looking at it, it doesn't make any difference. I don't care. The only thing that the real test in physics is experiment, and history is fundamentally irrelevant. It has to do with curiosity. It has to do with people wondering what makes something do something. And then to discover that if you try to get answers, that they're related to each other. That things that make the wind make the waves, and the motion of water is like the motion of air, is like the motion of sand. The fact that things have common features turns out more and more universal. What we're looking for is how everything works, and how everything is, what makes everything work. But it's curiosity as to where we are, what we are. It's very much more exciting to discover we're on a ball, half of it sticking upside down. It's spinning around in space. It's a mysterious force which holds us on. It's going around a great big glob of gas that's burning fueled by a fire that's completely different than the fire, any fire we can make. Well, now we can make that fire, nuclear fire. No. But that's a much more exciting story to many people than the tales which other people used to make up who worried about the universe, that we were living on the back of a turtle or something like that. They were wonderful stories, but the truth is so much more remarkable. And so what's the pleasure in physics is that, to me, is that as it's revealed, the truth is so remarkable, so amazing. And I have this disease, and many other people who have studied far enough to begin to understand a little of how things work are fascinated by it. And this fascination drives them on to such an extent that they've been able to convince governments and so on to keep supporting them in this investigation that the race is making into its own environment.